Good morning. It's July 17th, and this is your daily brief in science. Here's everything you need to know. 8 babies have been born in the UK using a new 3-person IVF technique called mitochondrial donation, aimed at preventing mitochondrial diseases. This method was tested on 22 women at high risk of passing on mitochondrial genetic disorders and resulted in 8 successful pregnancies, with 1 woman still pregnant and no miscarriages reported. The births are documented in the New England Journal of Medicine and are part of a regulated process in the UK, where as of July 2025, 35 patients have been approved to use this technique. The procedure involves transferring nuclei from a mother's fertilized egg into a healthy donor egg, replacing defective mitochondria, which significantly reduces mitochondrial DNA mutations in the resulting newborns. Experts highlight this technique's significance, noting it expands reproductive options for couples who cannot avoid genetic diseases through traditional testing. While the children are generally healthy, some experienced minor complications, such as elevated levels of abnormal mitochondria or high blood fat, but these are not currently considered health risks. The contribution of donor DNA is less than 1% and does not influence traits, ensuring the children inherit most of their genetic makeup from their parents. The UK legalized mitochondrial donation in 2015, becoming the first country to permit such research, whereas the US still prohibits clinical use due to concerns about heritable genetic modifications. In the US, regulations currently ban similar techniques, with ongoing debates about potential future changes. The UK's legal framework change facilitated this research, contrasting with the US, where such practices remain banned. Defective mitochondria, inherited only from mothers, can cause severe health issues like blindness and seizures, affecting approximately 1 in 5,000 people. Leading experts describe this as a major scientific breakthrough that offers hope to families affected by mitochondrial diseases, with ongoing assessments planned for the children's development. A recent study led by Dr. Nathan Caruana at Flinders University highlights the importance of timing and context in eye contact during human-robot interactions. Published in the Royal Society Open Science, the research shows that humans respond to social cues from machines similarly to how they respond to humans. The study, titled "The Temporal Context of Eye Contact Influences Perceptions of Communicative Intent," is set for publication on July 16, 2025. It emphasizes that integrating human-like gaze behaviors into robots and virtual assistants could improve their communication effectiveness. The Havoc Lab is expanding its research to examine how factors like gaze duration, repetition, and perceptions of a partner's identity influence understanding of eye contact, including whether the partner is human or AI. The findings have broad implications for fields such as robotics, psychology, and communication studies, and could transform nonverbal cue interpretation. They are especially relevant in high-stakes environments like sports, defense, and noisy workplaces, where visual cues are crucial. The research involved 137 participants and identified a specific gaze sequence, looking at an object, making eye contact, then looking back, as most effective for signaling requests for help in virtual settings. This is the first study to highlight the critical role of eye contact timing in social understanding, marking a significant advance in social and communication sciences. Ongoing efforts aim to develop technologies and training to foster clearer, more confident interactions between humans and robots, starting with mutual gaze improvements. Additionally, other research has shown that certain molecules can rejuvenate aged human cells and extend lifespan in C. elegans, which may have future implications for age-related cognitive and communication functions. Overall, these studies underscore the importance of nuanced eye contact cues and their potential to enhance social interactions across various domains. Researchers at Duke and Vanderbilt are working to increase the availability of hearts for transplant, particularly from donors who experience circulatory death. At Duke, surgeons successfully transplanted a heart into a 3-month-old infant using a new method that involved briefly assessing the heart's function on a sterile table after removal. Vanderbilt employs a simpler preservation technique by infusing the heart with a nutrient-rich solution before removal, which helps with transport and maintains organ viability. Traditionally, most heart donations come from brain-dead donors, with organs kept on ventilators until recovery. Circulatory death donation involves recovering organs after a patient's heart stops due to withdrawal of life support, but this process poses challenges because of oxygen deprivation before recovery. Concerns about the viability of DCD hearts stem from the oxygen deprivation period, which can affect organ quality. In 2024, 43% of deceased organ donors in the U.S. died via circulatory death, but only 793 out of 4,572 heart transplants used these donors. This highlights the ongoing organ shortage and the need for improved recovery methods. While nearly half of deceased donors are from circulatory death, only a small percentage of heart transplants utilize these organs. Traditional recovery techniques like normothermic regional perfusion are controversial and banned in some hospitals due to their complexity. Vanderbilt's Dr. Aaron M. Williams states that DCD hearts perform similarly to those from brain-dead donors, supporting their increased use. The demand for transplantable hearts remains high, with hundreds of thousands of adults suffering from heart failure and about 700 children added to the transplant list annually, of whom 20% die while waiting. Emerging techniques aim to provide simpler, less controversial recovery methods that do not require expensive machinery, making them more practical for small hearts needed by young patients. A recent discovery sheds new light on the origins of supermassive black holes. Scientists identified a rare ring-shaped galaxy duo called the Infinity Galaxy, which appears to host a black hole formed through direct collapse. This finding was made by analyzing data from the Cosmos Web Survey and conducting follow-up observations with NASA's James Webb Space Telescope. The JWST images provided crucial clues about black hole formation in the early universe. Researchers plan to measure the velocities of the black hole and surrounding gas to determine its origin. Preliminary data shows the black hole's velocity closely matches that of nearby gas, suggesting it formed from local material. This supports the heavy seeds theory, where massive black holes form rapidly from collapsing gas clouds during galaxy collisions. The black hole is located between the two colliding galaxies, not within their nuclei, which is unusual. Van Dockum notes that such galaxy collisions were rare but possibly more common in the early universe. This discovery is considered a potential smoking gun for understanding black hole formation pathways. It provides the first observational evidence of a black hole forming from direct gas collapse outside a galaxy's nucleus. A new study from Harvard T.H. Chan School of Public Health reveals a clear link between proximity to Coldwater Creek in Missouri and increased cancer risk. Residents living within 1 kilometer of the creek report a 30% cancer rate, compared to 24% for those living more than 20 kilometers away. The research focuses on childhood residents near Coldwater Creek and finds higher risks of radiation-related cancers such as thyroid, breast cancer, and leukemia. These risks are likely connected to exposure from nuclear waste associated with the Manhattan Project era. The study, published on July 16, 2025, in JAMA Network Open, confirms long-standing community concerns about radiation exposure from uranium processing waste. Researchers analyzed data from the St. Louis Baby Tooth Later Life Health Study, which previously detected elevated radioactive isotopes in children's teeth from the period of nuclear testing. The investigation was conducted by a team including Mark Weisskopf, Michael Leung, Ian Tang, Joyce Lin, Lorelei Mucci, Justin Farmer, and Kaylee McAlane. Funding came from several NIH grants, and lead author Weisskopf highlights the public health implications as nuclear development expands globally. The study notes limitations such as reliance on self-reported cancer diagnoses, indicating the need for further research to verify these findings. The results support community fears about health issues linked to Coldwater Creek, contaminated by uranium waste from the Manhattan Project. This research coincides with the inclusion of the Radiation Exposure Compensation Act in a bill signed by President Trump on July 4, 2025, offering some relief to affected residents. The study analyzed data from 4,209 individuals who lived near Coldwater Creek as children during the 1950s and 1960s, when contamination was believed to be at its peak. The U.S. Army Corps of Engineers has been involved in remediation efforts, acknowledging that contamination levels were likely much higher during the mid-20th century. Overall, the study underscores potential health risks associated with nuclear waste, especially as nuclear power and weapons development continue worldwide, even at lower radiation exposure levels. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.